Hi guys, today we're going to learn about polynomial applications and solving polynomial inequalities. So for the first problem, you need to write a possible function for each graph that passes through the given point. They are giving you here your point, and then they give you this beautiful polynomial. So the first thing that you need to see is I have the x-intercepts here, 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 and here. Okay, so I have three. What I like to do first, I recognize my roots, okay? So I'm going to write my roots here, okay? And also I'm going to write the multiplicity. I start with this one. I know that -4 is a root. In addition, I know that because it's bouncing is multiplicity 2. Over here, I know that -1 is also a root. But here, it's just crossing through, it's passing through, therefore this is multiplicity 1, okay? So -1 is multiplicity 1. On the other hand, you have that 2, okay? So 2 you have a snake, okay? It's passing through, but it looks like a snake. Therefore, this is going to be multiplicity 3, okay? So these are your roots, okay? So we need to build a polynomial, okay? So I'm just going to call it, I don't know, px. I'm very original because it's polynomial, okay? So far, what do you have? I have that one of the factors is going to be x plus 4, and the multiplicity is going to be 2, or the exponent is going to be 2. Then the next one is going to be x plus 1, which is this one, and the last one that I have here is x minus 2, okay? But I have something here, okay? So how can we find that something? Well, what you can do is you can use your point, okay? I'm going to call that something a, okay? So I know that what I have is 20 is equal, because that's a y, it's going to be equal to a times 0 plus 4 square, 0 plus 1, 0 minus 2, and I forgot the cube here, okay, cubed, okay? So now you compute that, so you have 20 is going to be equal to a times, and you have that this is going to be 16, this is going to be a 1, and this over here is going to be -8. Therefore, what you have is going to be 20 equals -128a. Okay, so we know that a is going to be equal to 20 divided by -128. In other words, you have that this, if we simplify it, is going to be equal to 5 divided by -32. Therefore, your polynomial looks like this. 32. Okay, so now there's some things that you need to make sure that they match. First, the multiplicity. This is 2, 1, 3. Adding those is polynomial degree 6. So this is even polynomial. Okay, does it make sense that it's behaving the same way, the end arrows? Yes. Low, low. Does it make sense that it's negative? Yes, both of them are low. Okay, and that's pretty much it. Okay, I'm just checking that it was matching my expectations. Okay, so similarly here, what you have, let me put the arrows here and here. Okay, you are going to build up another polynomial p of x. Okay, I'm going to have the point 1, 8. So what do you have here? Your roots over here are going to be this one, which is -2. -2 has multiplicity 2 because it's bouncing. Over here, you have that 0 is going to be having another multiplicity. In this case, it looks like a snake, so I'm going to do multiplicity 3. Okay, another crossing part is going to be here, which that's at 3, but please note that it's bouncing. Okay, so it's bouncing, therefore it's multiplicity 2. Okay, so from there you have kind of your pseudo polynomial here. You have x plus 2, and that's going to be square. Then you have that one is going to be x alone cubed. Okay, and then you have that the next one is going to be x minus 3 square. Okay, so does it make sense that the multiplicity is 2 plus 3 plus 2? That is going to be 7. Low, high, yes. So what's your expectation here? My expectation is that this guy is positive. Okay, so but let's see if it's true. Now, what are you going to do? You're going to plug your point. Your point, let me do a line there so you don't get confused between the two problems. You have that it's going to be 8 is going to be equal to 1 plus 2 square times 1 cubed times 1 minus 3 square. Please note that this 1, 1, 1 comes from the point, okay, in case that you're wondering. So you have that this is going to be 8, and that's going to be equal to, and I forgot my a there, okay, so you have that it's going to be a, okay, this is going to be 9, this is going to be 1, and this is going to be negative 2 squared, okay, so that's going to be 4. Okay, so you know that this is going to be equal to 8 equals 36a. Okay, so you have that a is going to be equal to 8 divided by 36, which we know that we can simplify as what? 2 divided by 9. Okay, therefore you go and draw your 2 divided by 9 here. You know that this was an odd polynomial, which makes a lot of sense, and that's it. Okay, so that's for that. Let's move on to inequalities. Okay, so please note that it says solve the following inequalities graphically. Okay, so we need to use the graphic process and describe the solution set in set notation. Okay, so please note 2 important things. Okay, so the first thing that you are going to see here is I'm going to move this guy to the other side. Why? Because you know that I'm obsessed with having my leading coefficient positive. So I have that t power 3 minus 9t squared, it's going to be less than 0. Okay, after that I'm going to factor, okay, until I have all linear factors. That's always my goal. Okay, I realize that these two have in common t squared. Okay, so I take out that factor, so I have t minus 9 less than 0. Okay, so you realize that we found the roots. Okay, so from here I can draw a pseudo good idea of what I have. Okay, so I do my rough sketch here, y, x. Okay, so what do you know? Well, I know that 0, okay, is going to be one of my roots, and this root is going to be a double root. Okay, therefore it's going to be bouncing. In addition to that, I have that 9. Okay, and let me draw it here. Okay, so that's 9, this is 0. It's also a root, but that's a linear root, okay, or degree multiplicity 1. Okay, after that I need to recognize that the polynomial that I'm analyzing is a cubic polynomial, meaning this is an odd polynomial, meaning that it's going to behave not on the same way, but you see that this is a leading coefficient positive, therefore it's going to be low high. If it's low high, I do my low here, my high here. Okay, I know that 0 is going to be a bouncing part, so this is going to be my pseudo graph. Are we okay with that? So that's what we can see. Now you need to analyze, well, this inequality. Now let's move on to the actual inequality. This inequality tells you that this is true when your expression is less, strictly less than 0, meaning your x-axis will serve as a boundary, therefore the part that you want is going to be below the x-axis. Okay, so that's why I'm highlighting that part. Please note that this inequality is strict, therefore you are not going to include neither the 0 nor the 9. Okay, so what are we going to do here? Well, you can see your solution set. Okay, your solution set, let's do it with what's that, interval notation, and then we can convert that into set notation. Okay, so you see that it's going to be from negative infinity, and please remember that the inequalities are based on the x's. Okay, up to 0, you don't include the 0, and then you have that it's going to be union 0, comma, that's 9. Okay, so this is in not set notation, in interval notation. Now, if you want it in set notation, what you have here, it's going to be t such that, and the t is going to be less, strictly less than 0, union, and you know that the t is going to be in between 0 and 9 without including the extremes, and that's going to be your solution, okay, in set notation. And actually I should call that x instead of x. That should be a t. Okay, but that's what we have. Cool. Now let's move on to number 4. For number 4, similarly, we are going to move this one to the other side. Okay, so what we have here is you have x power 4 minus 10 x power 2 and then plus 9 less than 0. Okay, so now you see here that it's quite neat. Hopefully you see the pattern here that it's kind of like a quadratic function even though we have power of 4. So we can factor the situation. You can factor this. Imagine that you have u squared minus 10u plus 9. Okay, so two numbers that when you multiply them they give you 9, and when you add them or subtract them, negative 10. Well, you know that it's going to be x squared minus 1, x squared minus 9, and that's going to be less than 0. In addition, you're like, okay, I want linear factors, and these are not linear. Both of them are quadratic factors. You are like, oh, this is the difference of squares. Cool. Okay, so you are like x minus 1, x plus 1 is going to be these are going to be the factors of x squared minus 1. Similarly, you have that in this case you have x minus 3, x plus 3 less than 0. Okay, once you have this, you are like, okay, so all my factors are linear, so pretty much I have a good idea of how my graph looks like. Please note that this graph, immediately as you see it, is the even. Okay, the leading coefficient is even, well, the exponent is even, and the leading coefficient, you know that it's positive. Therefore, this one is going to be a high. Okay, so we know what to expect of the end behavior, so let's kind of like graph it here. So you have y(x), and this one is x actually. Okay, so we have that my first roots are going to be negative 3. Okay, we have the negative 1. Okay, then we have a 1, and then we have a positive 3 here. Okay, so I'm just going to mark them there. Please note that I'm going to include them. Why I'm going to include them? Because I have the equal. Okay, so we talk about the high. Okay, so you know that you're going to start high and end high. Okay, so you can see that all the roots in this situation are linear, therefore you are just going to cross through them. Okay, so your graph is going to look like this. Okay, so you're like, okay, cool. Now, let's analyze the inequality that you have here. As we were talking about, we are going to include the negative 3, the negative 1, the 1, and the 3. Okay? So now you have that it's less or equal. Therefore, in this situation, I'm going to include all of them. In addition, I know that it's below, again, the x-axis. Okay, so you can see there your solution. Now let's write it. I know that you like interval notation, so I'm going to do first interval notation and then set notation. Okay, if you do interval notation here, you know that it's going to be from negative 3, including it. That's why the bracket is square, to negative 1. I union this 1 to 3. Since I want set notation, you know that the set notation is going to look like, and I'm running out of space here, so it's going to be x such that, and my x is going to be in between negative 3 and negative 1, but please note that I'm including them. Union, again, 1 and 3, obviously I'm going to include them with the equal there, and that's your solution. Now for this part, we need to solve the following inequalities using a sign chart and describe the solution set in interval notation. So please note that here we need to use a sign chart. Okay, so thankfully we have interval notation that I know that you like better. Okay, so the first example that we have here, we have x squared plus x minus 2 times x squared minus 4x plus 4 less or equal than 0. So what I'm going to do here, I'm going to factor it even more. Okay, I wanted it to completely factor. Okay, so how can we factor this part? Well, you know that that one is going to be x plus 2, x minus 1. And this one is going to be perfect square, so you know that it's x minus 2 square, or x minus 2 times x minus 2, and it's less than 0. Okay, so we have this, and you're like, cool. Now what? How can I build my table? Okay, so you build your table by drawing a number line. Okay, so what I do, this is basically your number line. You know that you start at negative infinity and you end at positive infinity. What do you have in between? What are you going to write there? Well, the roots. Here, my first root, it's pretty clear that it's negative 2. Okay, so I just write here my negative 2. The second root that you have there is going to be the 1. The third root that you have over there is the 2. Okay, so those are going to be your two important points here. Okay, so after that, what you need to write here are the factors that you have. In this case, my first factor is x plus 2, the second factor is x minus 1, and the third factor is x minus 2 squared. Okay, so what you need to do here in this, basically in this interval, is choose a number that is in between negative infinity and negative 2 without including the negative 2. So in this case, I'm going to honestly pick negative 3. Okay, so I plug negative 3 here. When you plug negative 3 here, and the only thing that you need to analyze is the sign. You know that that's going to be negative 1, which is negative. I plug the negative 3 here, you have that it's negative 4, which is negative. Then you plug negative 3 here, which is going to be negative 5 squared, which you know that it's going to be positive. Okay, after that, you are going to plug the negative 2 here, which is going to give you 0, this one here, which is going to give you negative, and the negative 2 here, which is going to be negative 4 squared, which is going to give you positive. Okay, after that, you move on to the next interval. This interval, I read it as some numbers in between negative 2 and 1 without including the negative 2 or the 1. So I'm going to pick, in this case, I'm going to pick 0. 0 plus 2, you know that it's 2, which is a positive number. 0 minus 1 is minus 1, which is a negative number. Then you plug the 0 here, you know that negative 2 squared is going to be positive. And then you pick the plug the 1. Okay, so 1 plus 2 is going to be 3, which is a positive number. 1 minus 1 is going to be 0. And then you plug the 1 here, so you have that 1 minus 2 is going to be negative 1 squared is going to be positive. And then you pick a number in between 1 and 2. In this case, I'm going to select 1.5. If I plug 1.5 here, that's going to be 3.5, which is positive. If I plug 1.5 here, it's going to be positive as well. And if I plug 1.5 here, it's going to be square, so it's going to be positive as well. Then I plug the 2. This is going to be positive, this is going to be positive, and this is going to be 0. Okay. Similarly, I'm going to plug a number in between 2 and positive infinity. You can plug anything. It could be 10, 100, or simply 3. I'm going to plug 3. 3 plus 2 is 5, which is positive. 3 minus 1 is going to be 2, which is positive. 3 minus 2 is positive. Square is even more positive, so you have that. Now you're going to tell me what's up with all those signs. Okay, so you do a little line here, and then you are going to analyze. In this situation, you are multiplying the factors. So you are going to multiply these signs that you have. You know that negative times a negative is positive, times a positive, it would give you a positive. Okay, then you have that 0 times a negative, it would give you 0. 0 times a positive is going to be 0. Then you have that positive and negative. When you multiply them, they give you negative times a positive is going to be negative. Okay, in the same way that positive and 0, multiply them, 0 times positive is going to be 0. Then you know that positive times a positive is positive, times another positive is positive. Okay, so now this one, you have that positive times positive is positive, times 0 is going to be 0, and here you know that this is going to be positive. Now, you need to analyze what the inequality is telling you. They want all the numbers that are less or equal than 0. So let's highlight the parts that you want. You want the equal to 0, so you want that, that, and that. In addition, you want when it's less than, meaning negative. Okay, so you want that part, the highlighted part. Okay, so since they are telling you to do interval notation, that's what we're going to do. Remember, these are just the singleton numbers. Okay, so you're like, okay, so I want the negative 2. Okay, so it's going to be from negative 2 to 1. Okay, I'm including them, therefore I'm going to have my square parenthesis union, okay, this guy, and you're like, oh, but it's only 2. How can I write that? Well, you can write it as this interval, right? That would be your interval, and that's correct. Okay, and that's it. That's your answer. Not that bad, right? So the issue is building the table. Okay, so let's build another table with this polynomial. Okay, so obviously what I'm going to do here is I'm going to move the 7x squared to the other side, because you know my obsession to have my leading coefficient positive and to factor, and you know how it works here. Okay, so look at the pattern. This is technically your quadratic term, your linear term, and your constant term, right? Even though this is power of 4, I know. Okay, so we can factor them. Okay, so you know that it's going to be x squared and x squared. Okay, and those factors are going to be x squared minus 9 and x squared, and you have that in this case it's going to be plus 2. Okay, so you realize you're like, this one is not as pretty, because this one I can do x minus 3, x plus 3, but this one I cannot factor it more. What are we going to do with imaginary roots? Okay, so you just leave it like that. Okay, clearly we are not working in the complex plane. Let's therefore you just leave it like that. Okay, so we start our table naturally. Okay, so you know that it's going to be from negative infinity to positive infinity. After that, you know that your roots are going to be what? Well, you only have 2 roots. Okay, this is a complex root, therefore you don't take it in account for the number line, because we're talking about real numbers. Okay, so you have that it's going to be negative 3 and positive 3. So let's analyze. Okay, so I need my factors. Of course, I was forgetting my factors. Okay, so you have here your factors. Okay, if you want to do the line before, you can do that. Okay, so pick a number in between negative infinity and negative 3. In my case, I would pick negative 4. If you plug negative 4 here, what do you have? A negative. If you plug negative 4 here, you have another negative. If you plug negative 4 here, so you're going to have negative 4 squared plus 2, that's going to be a positive. Okay, then you plug negative 3. This one is going to be negative, this one is going to be 0, and this one is going to be positive. Okay, now if you plug any number in between negative 3 and 3, honestly I would plug 0. So for 0 you have that's negative. If you plug 0 here, this is positive. If you plug 0 here, it's positive. Okay, then we put 3 here is going to be 0, 3 here is going to be positive, 3 here square is going to be 9 plus 2, that's a positive. And then you select a number in between 3 and infinity. Obviously here I'm going to select 4, but you can even select a million, right? So 4 minus 3 is going to be positive, 4 plus 3 is going to be positive, 4 squared plus 2 is going to be positive. Okay, again ask yourself, what are you doing with your linear factors? I'm multiplying them. Okay, so again I'm going to multiply. Negative times negative is a positive, times a positive, you know that that's positive. Then you're like, negative times 0 is 0, 0 times positive, that's going to be a 0. Okay, so you can go ahead and put the 0 there. Okay, so if you have a 0 and you are multiplying them, you know that that's going to be 0. Okay, then you go and it's negative times a positive, that's negative, times a positive, it's going to be negative. Okay, and this one, you know that positive times a positive is going to be positive. Okay, so read here your inequality and you realize that you want when it's less than, strictly less than 0. Therefore, the only part that you want from this table is going to be this part. Okay, since we only want that part, you know that your solution in this case is going to be from 3 to 3, and you are not going to include the extremes, and this is going to be your answer. So to solve problems regarding application of polynomials, this is what we are going to do. First, you need to identify the variables, write an equation, determine the reasonable domain, sketch the appropriate graph, solve the equation. Maybe you need a calculator, and if necessary you need to estimate your solution to the nearest 1,000. Okay, so let's read this problem. A manufacturer has a square piece of cardboard 12 feet on one side. Okay, so what you have so far here, you have a square. okay, and it's 12 feet. Okay, so that's what you have. Since it's a square, you know that these are the same, so 12 feet also here. Okay, so an open top box is to be made by cutting out a square of the same size from each corner and folding up the edges of the piece of cardboard. Okay, you need to write a polynomial function to represent the volume of the box in terms of its height. Okay, so you know that you have a square piece of paper, that we have it there, well, of cardboard. Okay, and we're going to cut a little square on each corner, so you have something here, and something here and here. Okay, so what you have here is, it's going to look like, well, you have basically a square. Imagine that that's your square, and then since we're going to cut a corner, we're going to cut a corner of here, here, and here. This is how your new piece of cardboard is going to look like. And what they are telling you to do, let me take out this one, you are going to fold the edges and you are going to have this 3D object. You can see that this is going to be the top of your box. You see it? Okay, so let me leave here my 3D object. Okay, so you need to write the equation to represent a volume. Okay, so let's identify the variables first. The first variable that obviously you need is V, okay, that it's going to be the volume, okay, and it's going to be in cube feet. Okay, the second thing that you need, if you need a volume, you know that the volume of a rectangular object is length times width times height. Okay, so what do you have that it's going to be the length? Okay, so the length is going to be, let's have my object here, it's going to be this length, okay, from here to here. That one, clearly, you know, if you have a square here, you know that this is 12 feet, okay? So the length, when you fold it, that length is going to be clearly less than 12 feet, okay? So what I have is that length is going to be 12 minus 2h. Why? Because this little square that you have here, this is h and this is h. Let me take out this one so it's not confusing. So the measure of this one is h. So if you take out h here and h here from this length, you have that length is going to be 12 minus 2h. Okay, and you know that this is going to be basically the length, okay, in feet. Okay, then we go to W. What's going to be W? Well, W, if you are seeing it like here, it's going to be this one. Okay, that one, since it's a square, is going to be the same as the length in this case. So it's going to be what's W? The width, again in feet. Okay, and last but not least, let me fit it here. You know that h is going to be just h, okay, that it's going to be the height also in feet. Okay, so you realize, and why do you know that it's h? Because when you fold it, you know that that's your h. Okay, so this one, basically this measure is h. Okay, so you can see it. So we create our equation. Our equation, from this information, you know that the volume with h, with respect to h, is going to be equal to 12 minus 2h squared times h. So this is your equation of the volume. So when you analyze your equation here, you are like, hey, this is a cubic equation. Okay, so this is an odd equation. In addition, I know that my roots are going to be 0 and this is 6. Okay, so I mark my 0. Okay, and then let's say that 6 is here. Okay, so you have that those are your roots, and let me just mark it there. Okay, empty and empty here. Okay, so what do you know? Well, you know that your leading coefficient, which is this guy, but it's square, so it's positive, it's going to be positive. So you have that this would be low high. Okay, after that you realize that the 6 is a double root. Okay, so when you do this situation, you need to do that as a parabola, so you have a situation like this. Okay, why we have this? Because this is an odd polynomial, this is an even root, specifically quadratic, and this one is linear. Okay, now I sketch my graph here. This is going to be H and this is going to be V. Okay, so what's going to be the domain here? Well, think about something. Can the height be negative? In a real life situation, that wouldn't be true. So this one is a no. Okay, so this one is no. Now another thing that you need to take in account. This one is cool. Why it's cool? Because everything is positive, so good. Now here, when you are here, okay, let's plug 7. If you have 7 here, if you plug 7, then you have 12 minus 14, so you have negative 2. Can negative 2 be the measure of the length and the value of the width? Absolutely not. So this one, it doesn't make any sense, because you would have 2 of the dimensions negative, so that one is a no. So your actual solution piece, it's going to be that makes sense for this problem, okay, for a real life situation, is going to be that. You are not going to include the 0 or the 6, because if you have that 0, then well, you don't have a volume. Okay, so that's for that. So visually you have this. Now state the reasonable domain. Remember, the domain is the x's, or in this case the h. Okay, so for the h, where you start and where you end, you start at 0, you end at 6, so you know that it's from 0 to 6, and you are not going to include the extremes, therefore you use parentheses. For the range, what you know is the range is the y. Okay, so the lowest point here that makes sense for your domain, it would be 0. Okay, and then the highest point would be this one that you don't know. Okay, so using the calculator, okay, I just plug it here in my calculator. Okay, and you have a situation like that. As you can see, this curve is a little bit longer than mine, but so clearly you see that there's a highest point there. What I would do in my calculator, I would go to menu, analyze graph, and I would select the maximum. After that, I would just select, you know, the highest point, and you have that the highest point is over there. It's 2,128. So I would mark it here 2,128. Okay, so you have it there. So clearly you know that now the range is going to be up to 128. Now you need to ask yourself, are you including that 128? And the answer is yes. Okay, so your range looks like that. Then the next question, it's like, what is the greatest volume possible? Okay, so you know that the greatest is the maximum. The maximum volume, you know that the volume is the y, so it's 128 feet cubed. Okay, so that one with the calculator. Please remember that this one you need the calculator, with calculator. Okay, there's no other way. But in calculus you'll learn how to find that number, but not yet. Okay, for E it says, using the volume equation from part A, aka this one, okay, find the dimensions of all the boxes that have a volume of 12. Okay, so what do you want? We want 12 equals, then you have that it's 12 minus 12h squared times h. Okay, we want to solve for h, and after we solve for h, we want the other two dimensions. Okay, so what are we going to do here? Well, we already have this in the calculator. Okay, so honestly, what I'm going to do, I would press here in your calculator tab. Okay, so let me see, tab. Okay, escape. Okay. So tab. Okay, I would put my 12 here. Okay, oh sorry, 12. Okay, I would graph it there. So clearly you see that there's two places that you are crossing your graph. Okay, so if we want to see it, I would zoom a little bit out. Okay, so we can see both. There you go. Okay, actually there's three. Interesting. Okay, so we have menu, okay, and then you analyze graph and you find all the intersections. Okay, so I would find my intersection here. Okay, that one is one intersection. Okay, so I would record that 0.086. okay, so I would have that h is equal to 0.086. Then I would record the next one. Okay, menu, analyze graph, intersection. Okay, so you have another intersection somewhere there. Okay, so you have that one is 5.24. okay, 5.24, and if you go closer to that one is 5.24.4. okay. So the next one that you have here, there's another one, if you see there in that little mess that we have. Okay, so we have that it's analyze graph, and then you have intersection. Okay, we have it there, and I don't know if you can see it there. Let me make it closer. No, you cannot see it, so let me just grab it. Grab it there so you can see it. There you go. Okay, so that one, okay, you want more decimals, there you go. Okay, so you have that it's going to be 6.6706. okay, or you can round this one a little bit, but first let's analyze the answers that you have here. Okay, so h 0.086. well, you have that it's somewhere here, right? So this one is a good solution. Now this one 5.244, this one is in this area, so this one is good. This one is 6.6706. this one, you know that it's in this area, so this one is not a feasible solution. Okay, so your two solutions that are going to be okay are these two. You know that with this two, you know that basically 12 minus 2h is going to be equal to 12 minus 2 times 0.086, and you know that that one is going to be equal to what? That one is going to be equal to, if you actually put all the decimal places, it's going to be equal to 11.828. okay, so with this one, okay, in the same way that you know that 12 minus 2h equals 12 minus 2, and instead of this one we can plug the 5.244, so there's two options. When we plug this in the calculator again, you have that it's 1.513. so what are your two options? Okay, the two options that you have are either 0.086 feet by 11.828 feet by 11.828 feet, and the other option that we have is this one and this one. Okay, so you have that the second option, it would be that the h is 5.244 feet by 1.513 feet by 1.513 feet. Remember, these two are the same in this equation because we have that the top of the box was a square. Okay, and that's your answer.